Welcome to Let's Talk Cabling, the award-winning podcast where knowledge is power and the low voltage industry connects. Hosted by Chuck Bowser, RCDD, we're here to empower installers, designers, and industry pros with the tips, stories, and best practices you need to stay ahead. From copper to fiber, standards to innovation, this is the show that keeps you plugged into success. So grab your tools, turn up the volume, and let's talk cabling. Let's Talk Cabling, your source for low voltage expertise and connection.
Wednesday night, 6 p.m. Eastern Standard Time. That can only mean one thing. Live after hours with your favorite RCDD, Chuck Bowser. You know it's me. Don't even try to pretend like there's some other RCDD who you like better than me. You know I'm the favorite. The favorite. It's funny I say that because people message me in social media and DM me through LinkedIn, and they always say my favorite RCDD. It just kind of cracks me up that people do that. So yeah, welcome to the thing. Let me see. Free is in the house. I don't know what free is. So welcome, Mr. Free. So we always start off every Wednesday night with what are you drinking? What are you drinking? So put in the chat box what you are drinking tonight. Some people it's after hours, so they may be drinking adult beverages. I don't drink them. Tonight I am drinking again Earl Grey tea. Earl Grey tea because it is cold in Florida. I made mistakes right before the show started. I went out to put the animals away. I forgot to put on a coat. Daryl, the RCDD's in the house. Yes. So I forgot to put on my coat. It was cold outside. People don't think about Florida. It gets cold in Florida. So there you go. Hey, did you catch Monday show? I did the third installment of estimating low voltage projects. And I talked about work breakdown structures, the benefits of a work breakdown structure, how to create a work breakdown structure, and some other stuff as well too. So it's a great episode. It's about 34 minutes long. I tried some new editing techniques. So I actually show you the spreadsheet that I use for the estimating class and stuff like that. And pretty cool stuff, man. I really like it. Do I know anybody working on the ITSM? I'd like to start a study group. Okay. All righty. So reach out, message me, send me an email, because I was just telling somebody on TikTok right before we started, I'm seriously considering starting a study group for the ITSM manual. I'm seriously considering it. So let's do that. Send me a message afterwards. Okay. Acronym challenge. The acronym for today's show is OFCP. OFCP. Put in the chat box. What does OFCP mean? Let's see how smart everybody is. I got 10,000 points to the first person who can tell me what OFCP. And of course, you know me, it ties in with the subject of the show, right? It ties in with the subject of the show. OFCP. It stands for optical fiber conductive plenum. Okay. So it's a fiber optic cable with a metallic interlocking wrap, right? So that makes it conductive. That's OFCP, which means it's got to be bonded to the ground on both sides. So that was the acronym challenge for today. Now let's get into the heart of the program. I got 10 questions that I've been collecting, 10 questions. And these questions are two requirements, because I put out a thing on social media for people to send me questions. I wanted people who had very little fiber experience to ask me about fiber. Okay, so these questions are going to be entry level fiber optic questions. All right, so here we go. You ready for the first one? Let me see, double check. All right, no thing there. So the first question comes from John Carter via LinkedIn. And John wants to know, what are the most common types of fiber optic cables and when should I use each? So let's start off with multimode first. Multimode comes in 5 different types: OM1, OM2, OM3, OM4, and OM5. The OM stands for optical multimode. Okay. optical multimode. So the OM1 is the 62 fiber that we have been installing since I got in this industry. OM2 was the first 50 micron. Now, OM1 and OM2 are now considered legacy fibers. Legacy, meaning you're not supposed to use them anymore for new installs. You can still use them for existing installs, grandfathered installs, stuff like that, but new installs, you should be putting in OM3, OM4, or OM5. So, what is OM3? OM3 is laser optimized multimode fiber. OM4 is laser optimized extended bandwidth. OM5 is wideband multimode fiber. So, why would you? Multimode fiber is probably the most commonly used fiber we use in our industry because it's going to be suitable for those shorter distances like backbone cables between buildings, backbone cables within the building, and maybe even fiber to the desktop, right? Now, the reason they're better for that is people don't realize this. Multi-mode fiber costs more than single mode fiber. It does, but the electronics that run the multi-mode fiber optic system are cheaper than single mode. So, and typically your multi-mode fibers are going to be using an LED as a light source, a light emitting diode, or it's going to be using VCSELs, vertical cavity surface emitting lasers. Because you see, the way the fiber works is it turns light on, turns light off, turns light on, turns light off. And each one of those is a 1 or a 0. And it sends that light down the core of the fiber. The core has a high index of refraction, so light travels down it really easy. Surrounding that core, you have the cladding. The cladding has a lower index of refraction, because the higher the better with that. So what that does, it acts like a mirror and keeps the light on the core. So that's how fiber works. They're called total internal reflection. There's a really good YouTube video on this. Look up oh gosh, what the guy's name? My mind just pulled a blank. Engineer guy, and type in how fiber works. He made a really good video that explains that concept. Now, single mode fiber comes in 2 flavors, OS1A and OS2. Single mode fiber typically will use a laser diode, so they can go further distances. Single mode fiber can go up to 50 miles. 50 miles. Multi-mode fiber, you can go thousands of feet, maybe 10,000 feet. You're not going to go 50 miles. So single mode fiber can go long distance, and they use laser diodes as their light source. Now, again, like I said, single mode fiber is cheaper cable wise, but the transceivers and stuff cost a lot more than multi-mode do. So when you start talking about fiber, those are the 2 major types. And then inside those major types, you have inside plant and outside plant. So the outside plant typically is going to be what they call loose tube fiber. It's because there's got tubes in it and there's fibers inside those tubes, and they're laying in there loosely. So if you're in an area of the country, like Wired for Excellence is, he's in there on the TikTok feed saying hi. It gets cold there. It gives that glass room to expand and contract, expand and contract, expand and contract. And it's also 250 micron, which means that you have to use what's called a furcating harness. Now, some people call that a breakout kit or a fan out kit, right? Breakout kit or fan out kit. What that does, increases the size of the fiber strand, makes connectorization a little bit easier. That makes the connectorization a little more resilient. Okay, so you have the loose tube fiber. Inside plant, you have plenum or riser rated fiber, and it comes in armored fiber. It comes in tight buffered fiber. So tight buffer just means all the fibers are jammed all nice and tight up underneath that jacket. That's what that means. Okay, now armored fiber initially was designed to run cables in areas where you have a lot of traffic, or areas where you've an industrial plant. They were worried about something happening to that cable. But now we're starting to run armored fiber inside of commercial office buildings as well. Okay. Question number 2. This comes from Sarah Hernandez via Facebook. How do I properly clean fiber optic connectors? Every manufacturer, even the one I work for my day job, they all have specific sequence. They even got cute little acronyms to help you remember that. I don't know what to do, but basically is treat every fiber optic connector, every fiber patch cord, every bulkhead adapter as dirty until you clean it. Contamination is the number one enemy. So when you do the best way to clean fiber is to first do a dry clean. Okay, they make specific wipes to do dry clean. Dry clean it, inspect it, dry clean it. If it's inspected again, if it's clean, plug it in. If it's dirty, go back and dry clean it again, and then inspect it again. If it's still dirty, then you go to a wet dry system. 99% isopropyl alcohol in a lint-free wipe or some type of cleaning system. So dry clean, wet clean. Okay. So make sure that it's clean. Make sure there's nothing on that end face, and avoid touching that end face on that fiber optic connector, because there's oils in your hand. And when you touch that end face, you put some oil, you transfer some of the oil off your finger onto that end face, and that attracts dust. So clean it, plug it in right away. Clean it, put a protective cap on it right away. For those who may not know what a protective cap is, I just happen to have a fiber optic cable sitting on my desk. I am not sure why. That's that little white cap that's on the end of that. Okay, the little white cap. Those are called protective caps. They are not dust caps, like a lot of people seem to think they are. Okay, there we go. Question number 3. This comes from Mike Jacobs, and he sent this to me via email. He says, what's the difference between fusion splicing and mechanical splicing? Don't get your hopes up, but I was somebody reached out to me yesterday. It's a very well-known manufacturer of fusion splicers, and they asked me if I wanted one to play with. And of course, you know what I said? Yes. So there's a chance that I might get my hands on a fusion splicer in the very future. I'm going to be making content if they do. So fusion splicing and mechanical splicing. I think for performance-wise, fusion splicing is the best. Fusion splicing, and they're pretty simple. You strip and cleave the fiber, you put it in the fusion splicer, it lines the X and the Y axis up, and it splices those two fiber strands together. Your loss with a fusion splice is probably going to be 0.01, 0.02, maybe 0.03. You're permanently joining those two, you're welding those two fiber strands together. Very low loss, very durable, and I gotta say, they're extremely easy to do. A lot of people like to think that fusion splicing is hard. It is not. It is really, really easy to do. Mechanical splicing, now here's the thing. Mechanical splicing, you don't have to go buy a fusion splicer. So you're not going to dump out thousands of dollars to get a fusion splicer. All you need is a mechanical splicing rig. I think the Unicam one is like $1,200, I think, if I remember right. Last time I priced it. And then what you do is you're basically doing two mechanical connectors in one together, and it aligns the two fibers together, and there's an index matching gel inside of that to keep the light from escaping out. So mechanical splicing is less expensive, but you've got a mechanical splice, so you're going to have a higher loss. I've even had customers tell me that they don't allow any kind of mechanical connectors on their job site because of the reputation of mechanical splicing in the past. So, but it's out there, So for me, fusion splicing is going to be more reliable for a long-term solution, especially if you have a place where you're going to have a lot of vibration, because that's going to help protect against that. Again, if you have any questions, put them in the chat box. I don't see anybody putting any questions in. All right, so go to the next question. Question number 4. Looking at my notes. How can I ensure I have accurate optical fiber test results? How can I ensure that I have accurate fiber optic testing results? Okay. Number 1, make sure your test equipment is calibrated. All right. So that might mean sending it back to the manufacturer to get it calibrated once a year. Also, make sure that you reference your tester before you start actually doing the testing. Now, every manufacturer, Fluke, AEMs, Softing, Viavi, they all going to have different steps, but there's some generalities between those that are kind of all the same. Right? First, you got to pick a good known test reference cord. Now, test reference cord is not a regular fiber optic patch cord. It's an extreme low loss cord designed for testing. So get two good known test reference cords. You want to do what's called a one jumper reference. One jumper reference, you actually need 2 patch cords. Yeah. And what you're going to do is you're going to turn on the tester. You're going to wait for it to stabilize. Now, some manufacturers will tell you 2 minutes, some will tell you 15 minutes. You got to allow that light source to stabilize so now the power output is always the same. Once it's stabilized, you're going to connect your 2 patch cords, your test reference cords. You'll zero out that meter, and then you're going to disconnect. You're going to then put them to connect them together, and you want to verify that your loss is 0.15 dB or less for multi-mode, 0.25 or less for single mode. Then you're going to disconnect them, and then you're ready to go. Other things you got to watch out for is to make sure that you get the most accurate test results is make sure that nobody disconnects the test reference cord after you referenced it. If you disconnect the reference cord, you got to go back and re-reference it again, because even if you made it back in, you're not going to have the exact same loss, right? Not the exact same loss, right? So let me see. Was that a Swift or Fujikara? Also, what is your opinion on the brand TiniFiber? I saw them at Big C Conference in Las Vegas 2 years ago. I actually interviewed TiniFiber on a podcast episode. It's about time to have them on again. I think it's a real interesting concept, TiniFiber. It's a bend insensitive multimode fiber, and they put it in a armor wrap that looks a lot like the armor wrap that used to be on the old payphones between the headset. And you can tie them things in a knot, and you can get a lot more fiber in a lot smaller space. So I think it's a great concept. I don't have any experience installing it and terminating it because it came out after I left the field, but I have heard nothing but good reviews on it. So I hope that answers your question about TiniFiber. Question number 5. This comes from Trevor Wilson via TikTok. Hey, there's a way I can do a poll in here. Let me see here. Let me see if I can remember how to do this poll thing. And it ain't worth it. Hey, so answer me this question in the poll box. Right. Put in the chat box whether you think you can make more money at copper or more money at fiber. So put that in the chat box. Daryl, the RCD says problem with TiniFiber is it's not TAA compliant. TAA? You mean TIA or what's TAA? I don't understand. I'm hoping you mean TIA. So Trevor wants to know, what are some common causes of signal loss in optical fiber? Okay, so I already told you one, contamination, dirt and debris. That is the number one problem. There used to be other things in the past when we used to do 2-part epoxy connectors and stuff like that. So you used to have, bad cleaves. The fiber sometimes would break down inside the connector. Those are gone. No, but very few people are doing 2-part epoxy connectors. Today's environment, it's fusion splice on connectors, fusion splice on fiber optic pigtails, or some type of mechanical connector. Those are the 3 most common in today's environment. So in those environments, like I said, the number one problem is contamination. But there are other things that can cause excessive signal loss: micro bends or macro bends. Okay, so a micro bend is attenuation due to the deviation of an axis from a straight line. There's a definition for you. So the fiber has got a bend that you exceeded the bend radius. There are 2 bend radiuses that you need to know when you're installing fiber. While you're installing the fiber, you don't want to exceed 20 times the outside diameter of the fiber. When it's laying at rest in the tray, you can go to a smaller bend radius of 10. If you go beyond that, what will happen is that some light will escape out of that bend, and that's your signal escaping. Now, as long as you didn't fracture the glass, you can open it back up. It'll go back to working fine and dandy. Okay. Micro bends. The biggest problem with micro bends is over-tightened cable clamps, over-tightened tie wraps going into the enclosure and stuff like that. And then the other thing too is poor connectors or poor splicing. Your alignment wasn't right and you're getting it. But if you're doing fusion splicing, that's a beautiful thing about fusion splicing is it gives you the loss right then and there. Boom. Right then and there. Question number 6, how do I calculate the bend radius for fiber optic cables? This comes from Emily Ross via WhatsApp. Okay. So I already told you the 2 numbers. 10 times the diameter when it's static or laying into a tray, 20 times the OD if it's while you're installing it. So I'm going to run some numbers for you to make it real easy. Let's say your fiber optic cable is the outside diameter is 0.25. 0.25. Okay. And you can get the outside diameter from the manufacturer, from the catalog, maybe in distribution. So all you can do is multiply that 0.25 times 10. That's 2.5 inches. 2.5 inches. So you'll make sure that you avoid those pinching or kinking. So those two numbers are going to be extremely important. So let me see. Optical fiber is more niche than copper, but there's more money to be made with the amount of copper jobs. Excellent. Good input there. Question number 7. How do I troubleshoot optical fibers during installs? And this comes from Carlos Rivera via Snapchat. So probably the simplest way, the most cost-efficient way, is a VFL, a visual fault locator. I used to have one, but I gave mine away to a friend of mine who has a business in Pennsylvania. So I got to buy a new one. A visual fault locator. It's nothing but a fancy laser pointer that emits light in the visible spectrum that the human eye can see. And it puts that light down the fiber. So if you've got that macro bend, that entire bend will glow. If you've got a fracture, that will glow. You'll be able to see that through the jacket. Some manufacturers, for their mechanical connectors, recommend that you use the VFL during the termination process. So that way you can ensure that when you mechanically put those two together, you got a good connection. So, and a VFL, a good VFL, will probably run you about $100, $150. Be careful because there are some VFLs for sale on Amazon that are way too strong for you. If you look at a fiber optic cable with your unprotected eye, that could damage the retina in your eye. So watch out for that. Watch out for that. Now, if you don't have a VFL, you can certainly put a tier 1 test or optical loss test set on it. But the problem with the tier 1 test is it tells you if there's too much loss. It doesn't tell you where that loss is coming from. It might be the mated pair on this side, might be the mated pair on that side, it might be the splice in the middle, it might be a macro bend. You don't know. You just know you have too much loss. So an OTDR, which stands for optical time domain reflectometer, is while the tier 1 test is more accurate for loss, tier 2 testing, OTDR testing, will pinpoint where that loss is. You can actually do it. Look at the sample trace, and I'm working on a TikTok video for this. I meant to publish it today, but I forgot. I'm going to try to get it out tonight if I can. So you have two axes. You have a horizontal axis and a vertical axis, and you can literally see the signal getting weaker. And events will show up as certain things. So a connected pair will show up as a spike. A splice will show up a dip. And so you can actually move the cursors and measure just one connector point if you want. So OTR testing is great for troubleshooting, but the problem is most people don't run with an OTDR tester in their truck because they are not cheap. They're just not cheap. Question number 8. This comes from Olivia Brown via Twitter. What's the best way to protect outdoor fiber optic cabling? Okay, use outdoor rated cable. That's the biggest thing. Okay, outdoor rated cable will have a UV jacket. It'll be black in color to protect against UV. If it's a direct buried cable, meaning you dig a hole, you put it in the ground, you bury it, it'll have some kind of a gopher shield or rodent shield inside of it to keep gophers from chewing through it, right? And it's going to have some kind of a moisture barrier. Now, the moisture barrier can be icky pick or it can be a dry blocking agent. Icky pick is that gel-like material that gets all over your hands. Icky pick, by the way, if you don't know this, it is it's a petroleum-based product. Petroleum-based, which means it's flammable. It's flammable. Ask me how I know. Yes. Yeah. So some people like to use hydrosol, citrus cleaner to clean it off. Do not use anything flammable. I had a guy in a class one time told me he used gasoline to clean his fiber optic cabling. Gasoline. Yeah. BC's chiming on TikTok. He says, I hate icky pick. Join the club. Join the club, man. I should come up with a t-shirt that says I hate icky pick. I really should. Really should. So outside plant cables have the black jacket for UV protection, and outside plant cables will have the barrier and some type of moisture barrier. Now, outside plant cables, the majority of them are unlisted cables, which means they can't pass the test set out by this is Britton Corona from last study. Oh, hey, good to see you again. Um, so outside plant cable is unlisted, which means it can't pass the flame or the smoke tests. Okay, flame or the smoke test. But there is an indoor-outdoor rated outside plant cable for both copper and fiber, actually. So it's got a black jacket for UV protection. It's got some kind of moisture barrier, but it can also pass the flame test and the smoke test set up by the NFPA. So you have indoor-outdoor rated cable and outside plant cable. Outside plant cable is unlisted. Indoor-outdoor cable is listed, but it can run both indoor and outdoor. Okay, so that's the key there. Question number 9. This comes from Daniel Kim via LinkedIn. And he says, how do I ensure proper polarity of a fiber optic cable? That's a great question. 10,000 points to Daniel. Great question. Generally speaking, it takes 2 strands to make one channel, a transmit and a receive. So the strand that you plug in the transmit on one side, on the other side of the fiber, has to plug into the receive. So that means the old school way is we would actually take the patch cord and we would flip the patch cord. That way we make sure that the transmit goes to the receive on the other side. The problem with that is the IT person would disconnect the jumper to do some service work, and when they plug the jumper back in, they'd always forget to rotate the fiber. So the best thing to do is to use either a consecutive pair system or reverse pair system. So consecutive pair system, what you're going to do is you're going to land the fibers normally, blue, orange, green, brown, all the way up the Rosaka on one side, blue, orange, green, brown, all the way up the Rosaka on the other side. But on one side, on the adapter panel, you make sure that the notch, the opening is facing down. On the other side, you make sure that notch is facing up. That way, in order for them to plug in the patch cord, they have to rotate the patch cord to get it to go in. If you want to have both those adapter panels keyway up, then what you're going to have to do is on the one side, you're going to terminate it normally, blue, orange, green, brown, all up to rose aqua. But on the other side, you're going to flip the pairs. So it'll be orange, blue, brown, green. So you're doing the reversal behind the adapter panel. Okay. Doesn't matter which system you use. They both work equally well. There's no performance advantages to using any one of those. You can also even label your cords as well. So, but just double check everything, because nothing will make a customer more angry than hooking the fiber up wrong and they can't plug it in and get it to come up. Okay. Question number 10. This is the last question I have videoed ahead of time. So if you got a question, put it in the chat box, because I do have 3 minutes and I don't know if this question is going to last 3 minutes. What certifications or standards should I follow for fiber optic installs? You know, when I do the live streams, even though I don't go live on LinkedIn and Instagram and Facebook until 6 o'clock, I get on TikTok early and I get on and I talk with people. We were jamming out to some country music, right? And we were talking about certifications. So there are lots of certifications, right? In no particular order, okay, because I think they're all great certifications. You can get the installer fiber certification, the advanced fiber class from Bixby. You can get the CFOT, the CFOT from the Fiber Optic Alliance certification. We can get in a conversation which one's more widely known, which one's better for what type of work. But I'm always of the adage, knowledge is power. All knowledge is good knowledge. So get your certifications. Here's a question I want you to answer in the chat box. Do you think certifications are worth it? So put in the chat box, put in the message below. Do you think certifications are worth the money? Okay. I know how I feel about it. I feel they certainly are. Because when I got my RCDD, I was offered a $20,000 a year raise. Bam, like that. Because I had my RCDD. So, and yes, there's costs to maintaining that. You got to go to conferences. You got to do get your CECs. But your good reputable companies will pay for that renewal and pay for you to go to those conferences. So they are definitely worth it. Brayton says yes, they are. Oh yeah. So opinion on reversing fiber in the panel or with the patch cord. Should they be referred to as fiber A or fiber B? LOL. So if you're using the consecutive fiber positioning or the reverse fiber positioning, you don't have to label them. They would just some people will put A, B, B, and then or on the panels that works too. But if you do the consecutive or the reverse pair position, it doesn't matter because you can only plug it in one way because you've got that notch, and on that notch we've got those little clips that go into that notch. So the connector can only go one way. That's why I like the reverse pair positioning or the consecutive fiber positioning because you don't have to label TX on one side and RX on the other. So that's why I like that. So getting back to my question, sorry, so I answered the what certifications should they follow. So let's talk about the standards. Okay, so there are several standards. Now the TIA 568 series standards got lots of fiber stuff in it. There's lots of good free fiber optic training, by the way. I mentioned FOA. If you go to fiberu.org, they got free fiber training. John Bruno from Fiber Instrument and Sales, okay, FIS. He's got a free 2-hour video. Fiber training, free. Look up free 2-hour fiber training. For the cable guy's in the house. Hey, cable guy, I want to show you something. The cable guy's in the house. Yes. I still need to send you your stickers, man. I am so sorry. I just with the winter and the spring, farm in the spring, and I gotta get it done. So yeah, if you're studying for your installer fiber, or installer copper, or if you're the Bixie technician, or even the certified fiber optic technician from FOA, go watch that 2-hour video from John Bruno. It's a great video. Great video, right? And that's going to help you. That's going to help you understand the content as you're going through it. So there you go. So that was the 10 questions I had there. Let me flip over to the chat box, see if anybody's got that thing there. So what is the best way to troubleshoot a ghost result from a tester? Also, what is a ghost result? Great question. A ghost result is a problem of reflection. So clean your connectors. That's where I would go to first. So there you go. Jeff's in the house. Hey, Jeff. So cable guy saying, hey, buddy, that's awesome. No rush, man. Yes, but you know what? That's no excuse. Because look, hey, just to show you that I intend to do it, I still got the envelope that you sent me. So I got your address. So I'm going to take my wife off. I will get your stickers out Saturday. I will literally go to the post office and drop them in the mail and send them to you because I'm supposed to be working on the chicken coop, and I'm just going to have to take some time and send it to you because that's way overdue. And that's my fault, not your fault. So, all righty. So I hit all my 10 questions there, all my questions there. So look at that. We did it. So now make sure that you subscribe to the podcast. Hey, I'm trying to break some new numbers here. So if you're not already subscribed, subscribe on YouTube. Look me up on LinkedIn. Look me up on TikTok as well. Hopefully TikTok will be around for a lot longer. Hopefully it doesn't go away anytime soon. I certainly hope it doesn't. But, hey, trying to grow the channel. I will be at Bixie in February. I'm going to be at my day job. So if you see me, stop me. I will have brand new stickers. I ordered 100 of the Knowledge is Power, 100 of the Let's Talk Cabling stickers to give for everybody. So now, with that being said, knowledge is power, my friends.
Thanks for listening to Let's Talk Cabling, the award-winning podcast where knowledge is power and the low voltage industry connects. If you enjoyed today's episode, don't forget to subscribe, leave a review, and share it with your crew. Got questions or ideas for the show? Chuck wants to hear from you. Stay connected, stay informed, and always aim for excellence. Until next time, keep those cables clean, your standards high, and your future bright. Let's Talk Cabling, empowering the industry one connection at a